So let us work out one problem using cascaded amplifier. So here the figure shows a two-stage cascaded amplifier. The second stage is a common collector and the first stage is common emitter. So because we have taken the output across emitter, the second stage is common collector, and in this case the output is taken from the collector, so this is a common emitter stage. So a voltage source with a source resistance 1K, the RC1 collector resistance 5K, and the emitter resistance or the load resistance for the second stage is also 5K. So we have been given the parameters of the corresponding stages, common emitter and common collector. So we have to determine the input and output impedances and individual and as well as overall voltage and current gains of these stages. So as I told earlier, in this kind of problems we have to proceed from the last stage to the first stage. We cannot determine starting from the first stage because you know the formula AI is given as HFE by minus HFE by 1 plus H naught into RL. That RL is the load resistance of this first stage. This cannot be calculated until you know the input impedance of the previous stage. So it is better to start with last stage. Okay. And also, in order to determine the voltage gain, we have to determine the current gain first, then the input impedance. Using those values, we can determine the voltage gain. So first, let us draw the equivalent circuit for this problem. So here, this plus VCC and minus VCC we can neglect. By drawing the equivalent circuit, we can get the picture in an appropriate manner for us. So this is RS 1K is connected to, so this is our first stage. So we can represent it as B1, C1 and D1. So this is coming to the ground. We can join them together. So if you, for the equivalent circuit, we will short circuit all the sources, so it will become ground. So this point will come like this. So this collector, so when you ground this point, because we have to short circuit the voltage source VCC, so this RC1 will come like this. So this is your RC1 5K. Then from the collector point again we are taking to the base. Okay. So this second stage emitter is connected to RE. So we can make it like this, which is also coming to the ground. This collector is coming to the ground. So this is B2, A2, this is C2. Okay. So this is the base current IB1. This is the collector current IC1. This will be with the second stage base current IB2. And here you will have IC2, and this will be IE2. So you will take always the conventional current entering towards the transistor terminals. So this will be Re2 equal to 5K. So here we are taking the output voltage V0, and you can take this is the voltage V2, and you can take this voltage as V1. So here you will have the input impedance of the first stage. So this will be your output impedance of the first stage, RO1. If you take this collector resistance into account, it will become RO1 dash. So this will be RO2. This is the final output impedance, RO. This will be your Ri2. So we can draw the equivalent circuit from this like this. Since VCC and VE are the voltage sources, we can short circuit while taking the equivalent circuit. So I brought the both points to the ground. So VSS to RS connected to the base. The collector is going to the base as well as to the resistor to the VCC. Since it is grounded, so this RC will be coming to ground, and also this is going to the base, and this emitter is going to the resistor, again that is connected to the ground because VE is shorted, and the collector is again directly coming to the ground. So we have connected like this. So this is the base current of the first transistor, collector current of the corresponding transistor. This is the base 2 current, this is emitter 2, and this is collector 2 current. Now we have to determine these parameters. So as I mentioned, we have to start from the second stage. That will be more convenient. So we can take first the second stage. And you know the second stage is a common collector configuration. So I have to make use of only these parameters, HIC, HFC, HRC, HOC. So in order to determine the current gain, individual current gain, for the second stage AI2 is given as minus HFC divided by 1 plus HOC into RL. So here RL is equal to Re2. Okay. So now we can substitute the values. HFC value is given as 51. It's already minus 51. So if you put with this minus sign, you will get 51 divided by 1 plus HOC value is 25 microampere per volt. So that is 25 into 10 power minus 6 into RL is this 5K, 5 into 10 power 3, because RL is equal to Re2. That is the only value it is available here. So you can determine the value of this one. So this will be coming, I think it is some 45.8. You can calculate and satisfy yourself. So determining the current gain, then I have to determine the input impedance for the second stage. So this will be given by our formula HIC plus HRC into the corresponding gain AI2 into RL. So that's why I told. So unless you determine this value, you cannot determine Ri2 because it involves this parameter. So HIC is given as 2K. Remember, whenever the K appears, you have to multiply by 10 power 3. You have to take always in ohms, amperes and voltages. Okay. So plus HRC is equal to 1 into the value determined here is 45.8 into the value 5 into 10 power 3. So this may come around 228K. So this shows that for a common collector, the input impedance is always very high. So wherever you need high input impedance, then you can make use of this common collector configuration. So we can determine these two parameters, then we can determine the voltage gain. So this we know, AI2 into RL by RE2. So substitute this value, AI2 45.8 into 5 into 10 power minus plus 3 by RE2 equal to 228 into 10 power 3. So we may get the value 0.99. So see, for a common collector the voltage gain is less than unity, because since we are taking the output across emitter, definitely this will be less than the base temperature voltage. So if you see the voltage gain, that will be less than 0.99. Okay.